whose honors project is called AREAT, about building a video game engine from the ground up. And excited to have our honors scorer here.
Thank you.
Does she like wear it now? Or?
You don't have to.
Up to you.
Take
Just
it
don't
away.
forget it.
Yes, hello. Today I'll be walking you guys through the development and creation of AREAT, a game that I've been working on designing and developing. The word AREAT is a Greek word. It means excellence, integrity, or virtue. It's very similar to chivalry, so oftentimes it also includes like courage or being brave, putting others first. So we'll be going through like kind of the core idea and inspiration behind the game, looking at maps and the game perspective. We'll be looking specifically at CSV versus JSON files, the program file structure, graphics, and then next steps. Let's get started. So the core idea is for AREAT is an MMO RPG with unique death mechanics and no leveling. So an MMO refers to massively multiplayer online, so it's a game with kind of a very social element. And then RPG refers to role-playing game, so it often is more story heavy. So an MMO RPG has a lot of story elements and a lot of social elements. Leveling in MMOs is often kind of grueling, slow, tedious. It's pretty straightforward. You start at level 1. You have not very many hit points. You kill things, you do quests, and then you level up and you can take on harder bad guys. You can do harder quests and get better loot. The hard thing about that is at any point in playing the game, there are areas that are lower level than you are, that you've probably explored more than you wanted to because you were stuck there until you could level out of them. But they're boring now because you've explored them, the bad guys aren't tough anymore. And then there are areas that are too hard because they're higher level. The bad guys will just kill them instantly. So at any point in time, there are areas that are either inaccessible or irrelevant. In AREAT, there is no leveling. There is a more focus on discovery and like exploration and story. Finding unique items. So different areas of the map won't necessarily have different level requirements. They'll have different types of equipment that might be better suited to those areas, or unique stuff that you can find in the different areas. So there's a lot of incentive to still explore, but not because you can't access certain areas yet. So the question you may wonder, is everything going to be too similar because there's no leveling? Ideally, map areas are distinct enough and that they're all interesting to explore, and the game rewards exploration. What if there's an area of the map that is not interesting to players? What if there's like a desert area that is just nobody plays in there because it's boring? That's a warning sign to the developers that perhaps that area needs something interesting in it, like a new quest or interesting monsters that drop unique loot, or maybe a mount that can only be gotten in this area. Is there not enough stakes or progression without leveling? Will players play for a bit and then be like, everything's the same, I'm gonna be done? Ideally, there is progression, but it's through the storyline, it's through the quests. It's through discovery rather than just trying to access an area by playing long enough. The other unique thing about AREAT is death mechanics. In most death mechanics, in most MMOs, death mechanics are relatively straightforward. You take enough damage that you don't have any hit points left. You die, you either have to wait a certain amount of time, or maybe you respawn somewhere farther away from where you were working on stuff. Usually there's some kind of, like, you lose a certain amount of money, or you drop your loot and you have to go back and get it. It's pretty much just a penalty for not being good at the game, which is not as interesting as it could be. So in Arete, each playable race has unique death mechanics. That is the core thing about Arete. There's a large focus on player interaction. The different playable races work really well together if the different death mechanics work really well together. It adds a lot of strategy to how you play, rather than just don't die. These are some of the original sketches of the characters and some of their abilities. At the bottom you can see there's an upon death. It's the death mechanic. So the Dryad is probably the most straightforward. When they die, a tree comes up where they died, and then they do just respawn. So they are relatively straightforward. The Satyr, when they die, turn into a goat. They count as a monster. Other players can kill them and take some of their loot. Or they can find a Dryad bush and eat it and respawn immediately. Because they're ghosts, they eat things. Furies are probably my favorite. They're quite fun. They have, as you can see, not very many hit points. But when they die, they become a ghost. Now they are monsters. They can attack other players until they regain all their hit points, and then they become a player again. So a lot of their attacks have to do with using hit points to do a lot of damage. So they go constantly back and forth between alive and dead. And so they work really well with somebody like a Dryad, who has a lot of hit points and can heal themselves. Because the Dryad can take the Fury hitting them a couple times, and then the Fury can do a ton of damage. The Naiads are water-based, so when they die, they turn into a puddle, and then when they need to find a body of water, and then it reconstitutes them, and they're fine. They also heal in standing water because of how they're made of water. That's a side note. So you might wonder, could this be tedious? Hopefully none of the death mechanics are too terribly complicated, and none of them take a terribly long time. Is it too dependent on other players? No. It's a lot more nuanced and strategic with other players present, but there is a workaround if there are no other players present. There are the areas where the Dryads respawn. Other players can go to respawn if there are just no other players around. So does that just take away the stakes for dying? Kind of, because it's part of the game. It's not just a penalty. So you use it strategically. You don't want to just die anytime. You use the mechanics when it works with your team members to make it work really well. Let's talk about maps and perspective. So the main two perspectives that I was waffling between were axonometric top-down versus isometric. Axonometric top-down is going to be it's pretty straightforward. It's a grid-based system that mimics 3D by creating a 3/4 view effect. It essentially layers things the further down the screen they are. This is common in farming sims like Stardew Valley, and also like some of the older Zelda games and Pokemon type games. Isometric is, as you can see, it's similar. It's diagonal. It takes a bit more math, but it's a similar. It's another perspective. It's used a lot more in MMOs, which is why it's relevant. In looking at them both, axonometric has a lot simpler math. Again, it's just a grid. Isometric has slightly more complex math. It requires trigonometry, which I do not have. Axonometric top-down has a lot simpler, it's a lot easier to gauge which direction and the distance between you and other creatures. Isometric feels a lot more real, but it is a little bit hard to gauge how far away things are and what direction you need to shoot. Axonometric is a lot more common for, again, cozy games like cozy games like Stardew Valley, Farming Sims, and like some of the classic Zelda games. Isometric is more common for more modern combat games. So we are going with axonometric top-down because that is, I don't have the math for the other one, so that is why. And also, I like the look of it, but it also helps that I know how to do the math. Let's talk about CSV versus JSON. These are two types of files that can store data that needs to be remembered from gameplay session to gameplay session. So like what kind of character you play, what its username is, what the maps look like. This is data that needs to stay and be able to be recalled. These are both types of files that can remember that. They do it in different ways. JSON is a lot easier for people to look at and read it and be like, yes, I can see what this is. CSV is lines of text, so it's a little bit harder to read. It's still very readable, but it is a bit harder to read. JSON has simpler code in the program in order to read it in the program. CSV requires more code in the program to read it. It is more efficient, but it also does take more code, and it's harder. It's a little bit less readable for the developer. JSON can store more complex information types. So like it can remember the difference between numbers and words and like a Boolean, which is a true-false statement, whether something is correct or like true or false. Whereas CSV can hold all of those, but it stores them essentially as sentences. So it goes, that number is a one-word sentence, and then you would have to do the job of switching it to a number in the program. JSON uses the JSON library of code, and CSV uses the pandas library, which is a great reason to use it. Unfortunately, JSON did work a lot better for what I am using it for. So you can see here, this is an entry for a map in JSON. You can see it says that in spaces, that is the map grid. That is what the map, like you can see, it's a square. You can kind of see that like there's X's in the middle. We'll talk about what those mean in a moment. But like it's easy to see like this is a big square map. And then it has entities listed below for like creatures and things that are on the map, such as a box at this position on the map. CSV, so on JSON, this G is one tile. In CSV, this whole line is one tile. So it's a bit more like it's just a line of tiles instead of a grid of tiles. So it's, again, it's not impossible to read, but it is a bit more tedious to read and figure out what it's, where things are. So that is why JSON is what we've chosen to work with. This is the same grid that I showed you the last slide. They're color-coded by different types. So the X's, when it gets parsed into the map, into the program, it'll take the X's and go, those are tiles that are impasse tiles. You can't go through them. So for example, this is a tree. You can't go through the tree. So if you try to walk into the tree, it'll stop your character. Whereas the other tiles, you just move through them. And then G would be for grass tiles, A for aquatic tiles, and then P is the portal tile that you would step on that to move to a different map. So that is kind of how the maps are laid out. Let's talk about the program file structure. So this is the program folder. The old files or stuff that I saved in case I needed it that aren't being used. Main is the main. It's the main program file that calls everything else. It's what kind of runs runs the rest of the code.
Right now, it's mostly testing because there's one file that'll be a problem. So, but it will not be testing.
The domain folder is where the core game logic is. So domain is going to hold stuff like how, rules for how players work. That they remembers that they have hit points and they have. It says that they have a status condition, and if they're on fire, it says what happens when they're on fire. It also has, for example, the domain folder has the different races that would say what the different behaviors of the races are. For example, the dryad, when they stand outside, they heal a little bit because they're in the sun and they're plants. So that's in domain. Domain defines rules for the system. Map is another object in the domain folder. Infrastructure holds the JSON files that we were talking about earlier. It holds files that hold data that get saved from session to session. So for example, the maps, player data, stuff like that needs to be remembered and accessed is in infrastructure. Session is kind of the orchestrator of everything. Main calls session, and session, it's like the stage director. It directs everything else that's going on in the program. Systems is in charge of behaviors and actions. So domain was in charge of the rules for like how the player works. Systems, or how the map works, systems is going to go, okay, well the player stepped on a portal, we're going to switch the map. And the map, it works with the map object. The client folder is in charge of the graphical user interface, or the GUI. That's going to be the visual side of the game. So when you push W to go up on the screen, the computer will go, ah yes. It will track how far up your character went, but it doesn't display it right now because there's no GUI. It doesn't show on the screen that your character moved from here to there. It will. That is an area that we did not get to this semester. It will be a future step. But speaking of graphics, we did design graphics. They're just not in the game yet. So let's talk about some of the graphics and what they will look like once they are implemented. These are some of the sprite sketches. As you can see, these ones are more the isometric view, so more diagonal. The ones on the far side there are axonometric top-down, so they're more directly head-on and directly to the side. So there was in thinking whether to do high detail art or more pixel art, high detail is more close to the original. Pixel art is a lot faster for the computer to render. It's a lot faster to produce. It's a lot more classic. It's a fun vibe. So in the end, I did decide to go more towards the pixel art style. So these are some of the sprite animations. This is the dryad. So straight on to the side and to the side running. Each of the different playable races has a kind of a unique color scheme. So the dryad is orange and green, and then the satyr is yellow and brown, naiad is blue, and then the fury is kind of a red and then a dark gray and silver. So they will all be pretty distinct on the screen. Easy to tell which ones are which. This is an example of what the background will look like. This is the area that the dryad would come back at, the elder growth. So that's then there's an animation for what the chest will look like when it gets opened. But there's water there around the tree and such. Nope, that's backwards. All right, let's talk about where this program needs to go in order to get finished, because it's not finished yet. In the immediate future, the first thing to get done would be the graphics to get it, so you can see what it looks like. That would be nice. The next thing would be to get the quest system working, which would require interaction with the non-playable characters, or NPCs, and then getting the inventory system working so you can find items, pick them up, and bring them to the NPC and give them to them. In the further along future, the next things after that would be a combat system, so you could actually fight things, because that's a main part of the game. And then multiplayer functionality, which I haven't researched a whole lot yet, hence why it's not done yet, but that's also a core part of the game. And then eventually I would like to make the characters customizable so that you can have a unique looking character, because it's helpful to do that when there's a lot of people running around. And that's everything. Do you have questions?
What were some of the languages and tools you used, both code-wise and artistically?
Yes, I used